Information Communication Technology. Lecture number 10. Cloud and Mobile Technologies. Plan of the lecture. First, mobile technologies. Second, history of cloud technology. Third, technologies of virtualization. Fourth, web of service in the cloud. Cloud and mobile technologies. Cloud computing provides us a means by which we can access the applications as utilities over the Internet. It allows us to create, configure, and customize applications online. With cloud computing, users can access database resources via the Internet from anywhere for as long as they need, without worrying about any maintenance or management of actual resources. Cloud computing architecture. Cloud computing architecture, application, platform, infrastructure. Mobile technologies. Mobile technology is a technology used for cellular communication. Mobile technology has evolved rapidly over the past few years. Since the start of this millennium, a standard mobile device has gone from being no more than a simple two-way pager to being a mobile phone, GPS navigation device, and embedded web browser and instant messaging client, and the handheld gaming console. Mobile technology has different meanings in different aspects. Mainly mobile technology in information technology and mobile technology in basketball technology. Mainly based on the wireless technology of wireless devices, equipment, information technology integration. Mobile cloud computing is the combination of cloud computing and mobile computing to bring rich computational resources to mobile users, network operators, as well as cloud computing providers. The ultimate goal of MCC is to enable execution of rich mobile applications on a plethora of mobile devices with a rich user experience. MCC provides business opportunities for mobile network operators as well as cloud providers. More comprehensively, MCC can be defined as a rich mobile computing technology that leverages unified elastic resource of various clouds and network technologies toward unrestricted functionality, storage, and mobility to serve a multitude of mobile devices anywhere, anytime through the channel of the Ethernet or Internet, regardless of a heterogeneous environments and platforms based on a pay-as-you-use principle. History of cloud technology. First, 50s. Yes, the basis of cloud computing can be traced back to the 1950s. The use of shared mainframe computers allowed business and schools to share a computer and access it from remote locations. The mainframe was the first cloud in the sky. Second, 60s, 70s, 80s. During this period, more computers found their way into business, schools, and homes. People began to share their computers with others, and it allowed them to access the information from different locations. The number of clouds were growing. Third, 19th. The Internet and virtual private networks exploded on the scene. Now there was a different place for computers to put information on. If you had access to an internet connection, you could find the information that was stored by other people on the internet. The VPN allowed people to create their own network of computers that could work together. Fourth, the present. Mobile computing is taking over the world. Not only do people want to be able to use their computer devices, they have anywhere they want. They also want to be able to have access to all of the things that they store on their device. The biggest problems that the devices have are the limitations created by memory space. Thanks to the use of cloud computing, the amount of space that people have is almost limitless. If they put something in the cloud, they can retrieve it later from their portable computer. The history of the cloud technology provides some insight of what is going to come in the future. Cloud computing will continue to expand and people will be able to do more with their computer devices than they ever imagined. The one thing that almost people will never realize is how long it has taken computers to get to this point in the first place. Technologies of virtualization. Hardware virtualization or platform virtualization refers to the creation of a virtual machine that acts like a real computer with an operating system. Software executed on these virtual machines is separated from the underlying hardware resource. For example, a computer that is running Microsoft Windows may host a virtual machine that looks like a computer with the Ubuntu Linux operating system. Ubuntu-based software can be run on the virtual machine. In hardware virtualization, the host machine is the actual machine on which the virtualization takes place, and the guest machine is the virtual machine. The word host is the history used to distinguish the software that runs on the physical machine from the software that runs on the virtual machine. The software or firmware that creates a virtual machine on the host hardware is called a hypervisor or virtual machine manager. Different types of hardware virtualization include A. Full virtualization, almost complete simulation of the actual hardware to allow software, which typically consists of a guest operating system to run unmodified. B. Partial virtualization. Some but not all of the target environment attributes are simulated. As a result, some guest programs may need modifications to run in such virtual environments. C. Para-virtualization. A hardware environment is not simulated. However, the guest programs are executed in their own isolated domains, as if they are running on a separate system. Guest programs need to be specially modified to run in this environment. Hardware assisted virtualization is a way of improving overall efficiency of virtualization. It involves CPUs that provide support for virtualization in hardware, and other hardware components that help improve the performance of a guest environment. A snapshot is a state of a virtual machine, and generally its storage devices, at an exact point in time. A snapshot enables the virtual machine's state at the time of the snapshot to be restored later, effectively undoing any changes that occurred afterwards. This capability is useful as a backup technique, for example, prior to performing a risky operation. Virtual machines frequently are virtual disks for their storage. In a very simple example, a 10 gigabyte hard disk drive is simulated with a 10 gigabyte flat file. Any requests by the VM for location on its physical disk are transparently translated into an operation on the corresponding file. Once such a translation layer is present, however, it is possible to intercept the operations and send them to different files, depending on various criteria. Every time a snapshot is taken, a new file is created and used as an overlay for its predecessors. New data are written to the topmost overlay. Reading existing data, however, needs the overlay hierarchy to be scanned, resulting in accessing the most recent version. Thus, the entire stack of snapshots is virtually a single coherent disk. In that sense, creating snapshots works similarly to the incremental backup technique. Other components of a virtual machine can also be included in a snapshot, such as the contents of its random access memory BIOS settings or its configuration settings. Save state feature in video game console emulators is an example of such snapshots. Restoring a snapshot consists of discarding or disregarding all overlay layers that are added after that snapshot and directing all new change to a new overlay. Desktop virtualization is a concept of separating the logical desktop from the physical machine. One form of desktop virtualization, virtual desktop infrastructure, can be thought of as a more advanced form of hardware virtualization, rather than interacting with the host computer directly via a keyboard, mouse, and monitor. The user interacts with the host computer using another desktop computer or a mobile device by means of a network connection, such as a LAN, wireless LAN, or even the Internet. In addition, The host computer is, in this scenario becomes a server computer capable of hosting multiple virtual machines at the same time for multiple users. As organizations continue to virtualize and congregate their data center environment, client architectures also continue to evolve in order to take advantage of the predictability, continuity, and quality of service delivered by their congregate infrastructure. Web of service in the cloud. A web service is a service offered by an electronic device to another electronic device, communicating with each other via the World Wide Web. In the web service, web technologies such as the HTTP are originally designed for human-to-machine communication, is utilized for machine-to-machine communication, more especially for transferring machine-readable file formats such as XML and JSON. In practice, the web service typically provides an object-oriented web-based interface to a database server, utilized, for example, by another web server or by a mobile application that provides a user interface to the end user. Another common application offered to the end user may be a mashup, where a web server can consume several web services at different machines and compile the content into one user interface. Thank you for attention.